Hi, I'm the Chief Engineer, Troy Jones for Red River Radio, and I wanted to talk to you a little bit about what we call sun outages or solar transits or even sun fade. It's an interruption or distortion of the geostationary satellite signals caused by interference or background noise from the sun when the sun falls directly behind a satellite, which is trying to reach an Earth station. The Earth station can be either trying to receive data to or transmit from back and forth to the satellite, but it occurs briefly twice a year. Sun outages occur before the March equinox in February and March, and after the September equinox in September and October for the northern hemisphere, and occur after the March equinox and before the September equinox for the southern hemisphere. At these times, the apparent path of the sun across the sky takes it directly behind the light of sight between an Earth station, like our studios, for instance, and a satellite, which we talk to. The sun radiates strongly across the entire electromagnetic spectrum, including the microwave frequencies that we use to communicate with the satellites, like C-band, Ku, and Ka-band satellites. So the sun swamps the signal from the satellite. The effects of the sun outage range from a partial degradation sometimes to a full destruction of the signal. And the effect sweeps from the north to south, approximately 20th to February to 20th of April, and from south to north from 20th of August to 20th of October, affecting all kinds of specific locations for less than 12 minutes a day. Interestingly enough, we've performed a solar calculator that'll tell us about these particular outages. And when we do about our studios locations, and of course, you know, we have multiple locations across the three-state region, the calculator says that we should be getting outages right around 1:30 every day from October 3rd through October 8th for this fall. Now, of course, that will change in the springtime, but we're not there just yet. So if you hear an outage on our stations between 1:30, 1:40 or so, between now and the 8th, you'll know exactly why. And if it's kind of technical mumbo jumbo that I was talking to you earlier about geostationary satellites and the Earth swamping the signal with the sun behind it, here's kind of a visual representation. If we had something that could represent the Earth, how about a globe? So you take the globe, and while the globe is actually spinning, there's a satellite in orbit around the Earth. Not to scale, but the idea is that the satellite is above the Earth in orbit, and as it's traveling with the Earth, it's communicating back and forth, right? It sends signals to the satellite and then back down to another place, like we do from our studios to our transmitter sites. Okay, so we're actually going up to space and back down every time for our transmitter sites. So the idea is while that satellite is communicating back and forth, here comes the sun. Da, 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 you know the song. So the sun comes along and does kind of like this, right, behind the satellite. So the idea is that the sun comes behind the satellite, north to south or south to north, depending on what you're talking about, and swamps that signal. So you can no longer get the signal from the satellite to the Earth because it's swamped by the sun. And I'll give you a visual representation of that here. So if you can imagine the satellite being about here, and then the sun comes along behind it, you can see all that, the signal degradation that occurs even with the camera, right? Where the satellite comes behind it and swamps that signal out. And pardon me, it goes from north to south and south to north. You get the idea. But that's the idea behind solar fade, what they call sun outages or sun transit outages that occur. And of course, we just hope you bear with us. Just remember, our signal does have to go to space and then back down to the transmitter site. So it goes from the microphone to the satellite receiver outside, then up to space, then back down to our transmitter site, then out through the air, then to your car antenna, then to your speakers, and then to your ears in about an eighth or a tenth of a second. So we're doing the best we can, and we apologize for the solar outages and solar flares, solar transit that you're seeing, or hearing rather, every spring and fall. But I hope that explains a little bit better and kind of tells you why we have those outages. Thanks.